Okay, back in short order. That didn't take too long. So this is part 6? 7. This is part 7. Okay, in this section we're going to do the bandpass filter that's in front of, and we're going to install the first IF amplifier. So that's all the parts here marked in blue. That only consists of B3, which is a yellow IF transformer, V2, which is the 9018. Once again, I use a G part because that's what I got. And R5, which is the emitter resistor to ground, 150 ohms. They printed it twice, and then this bypass capacitor here, 22 nanofarads. All right. Now, make sure that you connect this part here. What else can I tell you? I put the signal capacitor for injection at this pin right here. Also, you'll notice on some of the IF transformers when you install them, there may be on the input this is center tap, so there are 3 pins, but sometimes the third pin is not used for anything, and it just goes through the printed circuit board with no pad. Sometimes it goes through the printed circuit board to a pad that has no traces or connections to any other part of the circuit. So it's inconsistency on part of whoever did the board layout. So got to remember, you're probably not getting paid much money. What else can I tell you? Oh, one other thing about IF transformers. The reason why they're different colors is because they have different turn ratios. They have different number of turns on the primary, and they have a different number of turns on the output. Now, besides being a bandpass filter, this is also an impedance transformer. The impedance from collector to ground on an amplifier is high. The impedance on the input to the base of a common emitter amplifier is low. So you have a high number of turns to a low number of turns. So this means high impedance to low impedance. It also does one other thing which you think is not what you wanted, and truly it's not, but you get more from the impedance matching. You're going to get a signal reduction here, that if this ratio is like 10 to 6, then you get a 40% reduction in the signal. But this amplifier brings it up to the level it was on the input plus some more. So that's why you build amplifiers. Okay. One other thing that bothers me about this circuit is the fact that they use a resistor here. Now we haven't gotten to installing it yet, but this is counterintuitive because this is 1.4 volts here, right? So 1.4 volts through here. You're going to put 1.4 volts through here, through a low resistance, through 100 ohms to this point. So you've got a voltage applied here and here, both fighting each other at this point. I would have put a capacitor here, but what do I know? It would be interesting, and I may do it, is to remove this resistor and put a capacitor there and see what it affects, because the current through this transformer, the DC current through this transformer doesn't do anything. Okay? Because any energy caused by this current flow doesn't get transferred over here because you need an alternating AC field. But that's for you experts to look at. One of the things that I could do, and it's going to take, somebody's going to have to bribe me. I could take this radio and I could start from the beginning and use SPICE to analyze every section. Okay? And then we could, on the computer, play with these parameters and see what it does. Now I'm going to show you something else also. I forgot one other piece of equipment that I had that you may get because I brought it up earlier. We'll come back to that. Okay, so let's try this thing out. Now, here we go. Got it all wired up, ready to go. And I install this IF transformer, and that's the one we're going to try. Let me turn on the power supply. Turn it on. Whoops, my ground came loose. That's no good. Hear me connect it back up. All right, let's see if I can find. I had to put the signal generator on the other side because that's where the cap is. All right, we're ready. Turn on the power supply. I got 362 amps, milliamps. Whoops, let's not get amperes going. Okay, we'll feed it a signal, and you can hear it. Okay, now let me do something here. Okay, so now let's adjust it. Got my screwdriver. Once again, we'll count the turns. We're going to use our ears. One turn. Hear it getting louder. So that looks like I lost track. What did I do? Two. Well, let me back it out here. When I was concentrating on two things I was listening. Okay. 1 3/4. And that gets me a loud tone. Now let me turn down the amplitude here because I was listening by sound. But you remember we talked about the little audio scope. Now let me turn off the light here so that you can see the screen. And you can see the signal, and it's overrunning the input here because okay, so let me reduce the input. Also, I need to change the, let me restart this thing. I need to change the trigger level. Okay, that's high. Let's do it. So there's something about the trigger level. So let's take select auto. This one. Let's lower this. What does that do? Okay. Let me lower this thing right here. Okay, you can see the signal. Now, that's not a very nice sine wave. It may be that the sine wave from my generator is not a pure sine wave. So I don't know which is the fault. It's either the signal generator or it's the audio amp or the audio driver. If I reduce the amplitude and reduce the signal level, see it becomes half of it. The lower half looks sine wave, but the upper half just, it's a mess. All right. So let me increase the signal level here. Oh, let me just do it from the here. Okay, and let me go. I can't go any lower. Oh, yes, I can. Okay, it says that the amplitude of this thing is like 020. You can use the scope. I'll go back and tune the transformer. Higher level. Let me reduce this by 5. Let me reduce the amplitude. So you can use the scope. So it went from what, 0.02 to 0.1, but I changed the amplitude. So, but you get the idea. If you want a visual signal instead of audio, this will work. And we may use this when I get the last section built. Did I cover everything? I think I did, and I did in less than 10 minutes. So let me turn this off. Turn the power supply off. Okay. And disconnect things so that I don't. Ooh. I can tell you that little yellow transformer is warm. It's probably around 100 and, sorry, I'm about to use Fahrenheit scale, and I shouldn't do that. It's whatever, 30 degrees Celsius or something like that. So it's getting warm. Turn this off because I don't want to run my 9-volt battery down. I get 2 of them for $1, but I don't, try not to eat them all up. Okay, so my next section, and I got to get my, where's my regular schematic, because my printed thing here is not complete. Where is my schematic? Let's see if I got one that's complete. Oh, yep, here's one. All right, can't have too many schematics. So we've got first, second, IF amplifiers, demodulator, audio driver, audio power amplifier, all constructed. So all we need now is to tune in a signal. All right. I'm going to wait till the next video. Let me get on the next section. What we're going to do is we're going to build everything to the left of the pointer here. Okay. And that involves what is called an autodyne circuit. The primary and secondary of the red transformer are used to, this circuit here tunes 455 kilohertz, generates a signal above the station I want to listen to, and in order to oscillate, it needs some feedback through the collector through this winding here. Okay, and notice that there are 2 trimmers here. If you look at the capacitor, it's a dual section. See, that's what this dashed line here means. There are 2 variable capacitors. Okay, one of them is here. It's on the inside. One of them's here, and the other one is here on the second half. There are two in there, and then these these are trimmers, and that's the little variable capacitor here and here. There's 2 of them, one for each section here. This is the main tuning, but this is a fine tuning, and you set and forget it. Okay, and this is part of the alignment procedure. Okay, this is a bandpass filter. Okay, connected to the antenna. All right, and this is the oscillator tuning. So you remember the window for the IF transformer? Well, the bandpass filter that works with the tuning. Well, let me do this with a pencil. Okay, say there's some station here at 920 kilohertz. Okay, the antenna with the C1 variable capacitor here is a bandpass filter, so it's it's a window, and as you move the oscillator up, okay, and in fact the center frequency here and the oscillator frequency, the local oscillator, this difference here is 455 kilohertz. All right. So if I want to listen to 920, then the local oscillator has got to be shifted up here to 455 kilohertz plus the 920. So whatever that is, you do the math. I'm too tired. Okay. Well, this bandpass filter, consisting of C1 and L from B1, okay, that's going to be the large winding, I'm pretty sure. As you vary the capacitor C1, the dual sections, the local oscillator moves, okay, this distance, and the bandpass moves the same, and hopefully you got them so that the bandpass filter is on the station you want to listen to. It's exactly 455 kilohertz away from the local oscillator. Okay, the reason you do this is because this band filter is not wide enough to cover from 550 kilohertz to 1.6 megahertz. It's just too large a frequency range for an LC bandpass filter to cover. So it's a narrow window and you move it, okay? And that's the theory. There's more to it, but this is beyond the scope of this course. So we're going to go off and install 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. And the antenna consists of a ferrite rod and some very, very fine wire, okay? And we'll look at the original data sheet. This thing sits in there. One of the things that I found looking at it the other day is this rod is held by this little plastic piece here, and this is supposed to sit either below or I think below the circuit board, and the variable capacitor sits above, and the screws that hold the capacitor also hold this thing, but I find that the screws that I got are too short. And somebody can comment on how they work this out, but what I'm going to do is I'm going to cut this piece off here, and I'm going to epoxy this to the wall of the, make sure you do the right one. Okay, the printed circuit board is going to sit on this side, mount through this hole, and the antenna, this sits here when you get it all wired up, and this is to support it, keep it from flopping around. So I have to work that out. It's, you know, doesn't seem right to me, but the way things are set up, so I'm going to do it differently. Also, one other thing that I'm going to do differently is this tuning, the tuning indicator, which is displayed through the front window, has a little paper disc somewhere, here it is, that you attach, that you put on this thing, and you should align the red line along this trough here. But what I'm going to do is I'm going to throw this away, and I'm going to take some white paint and fill, or just with a toothpick, paint this here so that through the window you'll see red with a white stripe, okay? And one of the things that adjusting the trimmers on here is also not only to get 455 kilohertz difference, but to also align your tuning pointer with your dial. So we're going to do all that, and I've gone off to 19 minutes. I apologize. End of part 7, end of tape.